And I am live. That is pretty cool. Today is 31st of October 2025, Friday. And with that, let's just start solving questions. Yes, that is the thing. And like we have to think of some better strategy. Yeah, to grow. Practicing is cool. No, practicing is cool. Practicing is cool. I will start giving contests in a while now. In some time, I will also start giving contests. So that would be cool. The next contest is in November, 6th of November, global round. Yes, okay, I will give this contest. That would be nice. Okay, I will train myself before that. 7,000 people have registered. Yep, me included. And I want to do good. I want to do good in this contest. That would be nice. And if we saw, okay, okay, good people are already here. If I can solve 4 questions, that would be very, very nice. And yesterday there was the question of firewood. I think it was, no, it wasn't firewood. It was charming meals. Nope. In love block sequence. Nope. Submissions. Okay. Cool. And this one, knowledge cards. Let's rewrite the code for this one. And yeah, we'll begin with that. Emacs set Emacs attach TCP. And what does it say? Best day ever, life for real. Bro, this is real. Don't forget. Yes, I won't. Lazy one, update. And yeah, so sync. And we'll do this one. Like, yeah, we were doing this yesterday, but we messed up somehow yesterday. What were the things? Yep, we have deduct and yeah, deduct in case of no and yeah in case of yes. And yes, n, m, the size of the things and the number of the cards. Yes, and the cards are on the top left corner and they have to be transferred onto the like bottom right corner. And can the size, okay, n and m are both at least equal to 3. So shit, they will never be 1. They are at least equal to 3. Shit, okay, shit. Them being at least equal to 3 means we are 2. Shit, okay. So there was something else which was wrong in yesterday's contest. Hello, how is everything going on? And N, M, and A, the number of cards, C in N, M, and A, and then vector in A size, not N, A for int I, or int reference X in A, C in X, fill A, and okay, 2, int rem, like the number of cards which we have already removed, and long mx equals, let's make n into m, that is the total number of grids, and we cannot use 2 of them. And to put forward a card onto the grid, we need at least 2 places. So -2, because that is the total number of blocks we have on the grid, or squares we have on the grid, which are usable, and -2 again, because we need 2 extra blocks to put a card. Shit. Knowledge cards is the name. Knowledge cards. Okay. And yeah. Now, we just have to iterate. No, shit, I messed up. Here, we will not take the input like this. For int I equals 0, I less than k, I plus plus. There are k cards, and we want AI to mean the position of the I card from top. Makes sense. So, in C in C and C minus minus, because C is not zero index. C, it starts from 1, goes till k, and then A C equals I. I for the top card would be equal to 0, and I for the second card would be equal to 1, which, and I just means how many cards are above the current card. So that is nice. And MX is the maximum number of cards that can be above the current card. That is even nicer. Bool, okay, equals true, and then for I equals 0, I less than k, or first of all, we want the last card. So we will start from the back end while I is greater than or equal to 0 and I minus 1. So if the number of cards above the ith card minus the number of cards which we have removed is greater than the maximum number of cards we can afford to have, then okay equals false and break. Cool. Otherwise, see out depending on okay, yes or no. This works locally. Shit. Okay, yes or no are not the things. We have to say yeah and deduct. I think deduct. Yeah and deduct. Yeah. Huh. In the last one, this says deduct, even though it should be yeah, because yes, of course, because rem minus minus, or rem plus plus. We have removed one part. But this doesn't work when we submit, so there has to be some logical mistake in this some way. In some way, knowledge cards is the name and submit. And if this doesn't work, then we can look at the editorial. That will be fine. It is kind of stuck on test number 1 somehow. Shit, this is actually stuck. Test running on test number 2, and earlier it was wrong answer, and I guess it is still wrong. Okay, shit, this works now, but okay, why is this working? And what was the mistake earlier? Okay, we were taking in input ci minus minus and a size k long vector, that is fine. C minus minus ai equals 0. Okay, this was even wrong at this point, where okay in C taken into C minus minus AC equals I, bool, okay, rem equals 0, max is n into m minus 4 long, which is also fine. Okay, this is stupid. I do see the mistake now, and shit, this shit. The mistake was this: we had I as our iterating variable, but here we were comparing k and we were reducing k. So I was not changing, I was fixed. Shit, that is very stupid. Anyways, we can move on to the next question. And it's okay, let's also see what the correct solution for this is. Knowledge cards. Let's go. Shit, that was very bad. That was a very stupid mistake. Knowledge cards. This one. Author Nice, just random stalking, and Steven Novario. That is that is kind of crazy. 2100. 900 problems, but not a single problem, and only a few problems there. And the graph is pretty cool. This guy has solved a lot of high rated problems. That is cool. Nice. Back to this thing. Let card C with the card with number C written on it. Notice that we must put the cards in the stack N, N, M. NM is the ending cell where we want to put the cards and at the last in order from card K to K minus 1 till card 1. The key observation for this problem is that under given constraints, if we ignore cell 1 and M, we can always move any card to either n minus m and m or n m minus 1. Yes, makes sense. If and only if there is at least one empty cell, we can obtain this by considering the fact that an empty cell can move to any cell and can be used to rotate any 2 by 2 square of cells because 3 less than equal since n and m are less than equal to 3. If we ignore cells 1 and nm, each cell is a part of 2 by 2 square, which we can make a chain out of and take any brick wherever we want, moving a desired card to one of n minus 1 or n m minus 1 can be done by firstly moving the empty cell to the adjacent to the desired card, or whatever the exact procedure is, that does not matter, but the fact that we can do this does matter. Therefore, we can iterate the card in the stack 1 1 from top to bottom. While iterating, one should maintain all of the cards in the board that are not in cell 1 to m. Okay, shit. Yes, log k is the right time complexity, but k is the right time complexity and not k log k. We don't have to simulate, we just need to know if this is possible or not. Anyways, now on to, let's say there was a question in firewood somewhere. Firewood, let's do this. Okay. Shit, no, we cannot do this. Stopwatch because this one is in Kotlin and yes, so that is not good. Charmil's, we haven't done a lot of questions in this kind of garage. Let's do garage. Okay, garage it is. And yes, everything seems to be fine, working. Cool. And new Vim is also working. Cool. Okay. Pak Chanik, Indonesian name, plans to build a garage. He wants the garbage to consist of a square and a right triangle that are arranged in the following illustration. Define A and B as the lengths of the two sides in the right angle triangle as illustrated, and integer x is suitable if and only if we construct a garage with assigning positive integer values for both x and y, a and b, where a is smaller, it's strictly smaller than b, so that the area of the square at the bottom is exactly x. As a good friend of Park you are asked to help him find the nth smallest suitable numbers. Huh? Third, wait, what? An integer that represents the nth smallest suitable number, nth smallest x. The square of the area. Okay. Define A and B as the lengths of the two sides. An integer x is suitable if and only if we can construct a graph with assigned positive integer values of A and B so that the area of the square at the bottom is exactly x. Is exactly x. Okay, as a good friend, we have to give in the nth number. Area. Wait, yeah. Area of the total thing. So that the area of the square at the bottom is exactly x. The third smallest pseudo number is 7, as a square area of 7 can be obtained by 3 and 4. A square area of 7 can be obtained by assigning a equals 3 and b equals 4. A equals 3, and if b a is equal to 3, and if b is equal to 4, 3 4, then this side would be equal to 5 3 4. uh shit, this is 3, this is 4. The hypotenuse is 4, this is 4. One side is 3, so what would this side be? 16 minus 9 under root, that is 7 under root. Shit. Okay, so the side of this square would be 7, and this would be root 7, this would be root 7, and the total square would be 7. Makes sense. And smallest. Okay, area. A equals something and B equals something, and A is always strictly smaller than B, and what we want is B square minus A square to be as small as possible. This is our equation. Yes, this is our equation. We have this thing, and also A is smaller than B, and we have to give the ith number, and all the possible numbers which are like possible for this arrangement, we have to give them, we arrange them in increasing order. Then what will be the answer? And n can go up to 10 power 9, so we cannot just blindly calculate and do brute force and find all the values. So b can start from 2, b equals 2, and a can start from 1. In its case, b square minus 1 would be 3 under root 3, and the smallest area would be 3. Okay, let's write the smallest. The first answer would be 3. Then we cannot increase a, we have to increase b, because if we do increase a would be equal to b. That is not possible. So we go with b equals 3. 3 3s are 9, 9 minus 2, 9 minus 1 under root 9 minus 1. Shit, since we have to square the thing at the end, so we can just remove this, and yeah, we can just remove this, and we see a b square minus a square, right? And this thing is always positive. This thing is always, b is always greater than a. So a square of some number minus the square of another smaller number, as small as possible, right? So when b equals 1 4 9 25 and dot 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 dot, right? So yeah, when b equals 4, we can only choose a equals 1. When b square equals 9, we can choose a square equal to 4 and equal to 1. Okay, so we can have, next we would go with 5, and then the next smallest square would be 7, and then the next one would be 25 minus 9. 25 minus 9 would, wait, maybe not this. Can we have a difference of 9 here? Because the pattern seems like just odd numbers starting from 1, starting from 3, all the odd numbers. Can we have a difference of 9 somewhere? Shit, yes, 16, 16, 16, 25 minus 16 is 9. Yes, and then we can also have a difference of 11 uh, if we have 25. 36 is the next one. Then we have 11. Cool. But before that, shit, before moving in that direction, can we ever have a difference of 4? We can have a difference of 3. Yes, we will never have a difference of 4. But can we have a difference of 6? No, we cannot have a difference of 6. Nope. Can we have, wait, I'm getting a call somehow. And yes, audio is fine. That is nice. 11. Okay, we can have a difference of 3. We can have a difference of 5. We cannot have a difference of 6. Yes, it doesn't seem to be possible given these numbers. And yes, okay, we write this like more representable way, in a more representable way. 1, 4, 9. Then the next square is 16, then 25, then 36, and 49. Yep, let's say that. And what are the differences which are possible? So 3 is possible. 4 minus 1 is 3. Then 5 is possible. 4 is not possible. 4 is not never possible here, given these things. Then 5 is possible. 9 minus 4 is 5. Then 7 is 6 possible. 6 is also not possible, but 7 is possible. Then 8 is also possible. 9 minus 1 is 8. And 7 is possible. 16 minus 9 is 7. 6 is not possible. Yep, 6 is not possible. 8 is possible. 9. 9 is also possible. 25 minus 16 is 9. 9. 9 is possible. 10 is 10 possible. Shit, 10 is not possible. 11 is possible though. 11 is possible. 10. And 12. 12 doesn't seem to be possible. But no, 12 is not possible. 12 is possible. Shit, my bad. 12 is possible. 16 minus 4 is 12. But 10, why is 10 should also be possible? To get a difference of 10, that should be possible, but it is not. Okay, so we were unable to have 6, we were unable to have 4, and now we are unable to have 10. And is there a pattern? Can we have a difference of 13? Or can the differences repeat? First smallest is 3. Yes, no way around that. Then we do not have a 4. Then we have 1 5 here. 9 minus 4, that is 5. Then we do not seem to be having a 6. No. And then 7. We have 1 7, where 16 minus 9 is 7. Yes, that is it. And then we have 1 8, where 9 minus 1 is 8. 9 minus 1 is 8. And then 9, we have 1 9. 36 minus 25, that is 9. Yes, that is 9. And if we were to write down differences here, this increased by 3, this increased by 5, this increase was 7, this was 9, this is 11, then 13. So we certainly have all the odd numbers. And now we have a few even numbers somehow. Shit, the even numbers are just the sum of these in series, right? Shit, okay. So we have 3, we have 5, we have 7, we have 9, 11, 13. These are the differences in adjacent squares, 15, 17, 19, 21, and so on, right? And our final ascending series would be 3, then 5, then 7, and then 8, then 9. Then we already have done the sum of these two numbers. Then 7, 9, and then we do not have a 10. Yep, we do not have a 10. Yep, we do not have a 10. The next smallest number, the even number that we would have, would be 8. 8 is there. Then there is 5 plus 7. 5 plus 7 is this, 12. Yes, we can have 12 later. Right, after 9 we have 11. Then we have 12. 5 plus 7 is 12. Then we can have, wait, can we have a 12? Yes, one side can be 4 and the other side can be 2. Then the difference would be 12. That makes a lot of sense. See out Itachi, shoot, 0, 1, 2, 3. See Itachi plus 3. So that is crazy. Hello. Yes, these patterns. Yeah, we are doing this question here. Garage, not garbage. And shit, okay. That is this 3, I think, would be converted into char. And I guess at 3 there is no char. At there is no character with the ASCII value of 3, or not a visible character with the ASCII value of 3. So we will have here 3, and here we will have, here we will have T, and here we will have H. TH is TH the right answer to this thing. And this 12, 13, 13 is like, yes, all the odd numbers are possible. And for the even numbers, you have to check. Even 14 is 14 possible. Is for Can 14 be represented as a sum of two smaller odd numbers which are adjacent to each other? 3 plus 11, but 3 and 11 are not adjacent to each other. 12 was possible, 12, because 5 plus 7 was 5 plus 7. And not just 2, we could have 3 odd numbers. Like here, at some point, we can have 3 plus 5 plus 7, that would be 15. Shit, adding 3 odd numbers does not make sense. That would just result in an odd number. And yes, we cannot even have 3 odd numbers. We can have the sum of 3 odd numbers. If we do, like, one side is 5 and the other side is 2, then 5 square minus 2 square, 4, 21. We can have sum of 3, or even 4 odd numbers. 36 minus 4, that would be 32. We can have 32. We can have 32. I think after a point, every even number is possible. 14, yes, 15 is possible. Is 16 possible? 16 as a sum of odd numbers. We cannot use 1, we can use 3, 5, 3 plus 5, 8, 8 plus 7, 15. No, so we won't have that. But 16, yes, 9 plus 7, that is 16. So 16 is possible. Divide the number, divide the odd number by 2. It's, and if if the resulting number 14 was possible. I think after this, every number is possible. 17 is possible. 18 is 18 possible. 18 divided by 2, 9. 9 plus 9 is 18. Right. We do have a 9. We also have 5 plus 3, which is 8, but not 9. Shit. So we cannot have 18, it seems like. No, I said high as usual. It has equals 3 points to C and CHI. Okay, so this thing increase the first pointer, it seems. Okay, and this also increased. So, okay, makes sense. CHI value at index 2 in CHI would be I. And hi, hello. Given number, can we express the given number as a shit? Instead of finding out if we can express the given number as a sum of odd numbers, we have to see, can we not express it? I think if the number is divisible by 4, then like x, if x is divisible by 4, then we can divide it by 2 and we will get two numbers, like two even numbers, because original x was divisible by 4. So the resulting number is also divisible by 2, at least x by 2. And then we can do x by 2 plus 1 and x by 2 minus 1. And these two odd numbers are adjacent to each other. Therefore, sum is possible. The only thing that we don't have is a difference of 1. Yes, we cannot have a difference of 1, or yes, we cannot have a difference of 1. Yes, that is the only thing that we are lacking. So if one of these numbers turns out to be 1, we cannot have this thing. But also for 14, 14 is not divisible by 4. So 14 by 2 is 7. And yes, 14 by 2 is 7, but 14 is reachable. 14 is, wait, 14 is not reachable. Should, yes, 14 is not reachable. We cannot have a difference of 14, it seems. Yes, sure, 14 is also not reachable. So no, we can have this as a sum of two odd numbers. And if you want the current number to be a sum of two odd numbers, then this is the way to go. And if you want the current number to be a sum of four odd numbers, here 18 is the thing, and 18 is 16 is possible by 7 plus 9. Uh, let's say we add four odd numbers, 11, 20, 32, 32. This thing turns out to be 32. 32. If we add any two adjacent odd numbers, then the number that we get is going to be divisible by 4, it seems like. Right? Like here, If we add any two adjacent odd numbers, the result is going to be divisible by 4, because let's say this is our first odd number, then our second odd number is x plus 2, and if we add this whole thing, we will get 2x plus 2, and take 2 common, x plus 1, so divisible by 2, and since x was odd number plus 1, this is also even, so this is at least divisible by 4, so that is nice. And now the claim is, if the even number is divisible by 4, then we can reach it. All the multiples of 4 are reachable. Okay, so we have two series. Somehow all the odd numbers starting from 3 are reachable, and all the even numbers, which are a multiple of 4, are reachable. And if we add more than 2 odd numbers, if we add like 4 odd numbers, then what? If we add 4 odd numbers, so first, let's say the middle two numbers are x plus x and x plus 2, then the next number is x plus 4, and the previous number is x minus 2. These are the 4 odd numbers that we are adding. Hello, anyone watching BGMI tournament here? It is VMIC. I am excited to watch. Hello. Hey, how is your morning going so far? I am grinding CP today. What a great weekend today. Shit, let's go. Let's grind and solve questions and chill Nick. Shit, yes, I suppose weekends do mean for you because you get a holiday from your job, but for us, we are in college and we don't even go to college, so every day seems like a weekend. 4x plus 4. If we add this, if we add 4 odd numbers, and clearly this number is also divisible by 4, and not just 4, this number is divisible by 8, because this part is even since x was odd, and this part is already divisible by 4, so this is divisible by 4, this is divisible by 2, so the whole thing is divisible by 8. So that is nice. And shit, which means the numbers which are divisible by 4 are reachable ones, but the numbers which are divisible by 8 are reachable in two different ways, either by adding two odd numbers or by adding 4 odd numbers. Shit. And then if we, not just that, if we add 3 odd numbers, if we add the smallest 3 odd numbers, this, we'll have 15. So we are getting 15 in two different ways. Shit. 4 square minus 1 square, that would be 15. So we are getting 15 in two different ways. So numbers are going to repeat. Our original series, this thing, would also have repeated numbers. Shit, that is crazy. That is crazy. That is crazy. Shit, that is crazy. The third number is 7. The third number is actually 7. Shit. So we have to make this series, and this is changing tremendously. Okay, if not for the repeated part, this would be easy. But there is repetition. Given A and B, and the first number which is being repeated is 15. There are two ways to get up to not 15. There are two ways to get up to 8. No, there's just one way to get up to 8. Yes, there is just one way to get up to 8. 1 plus 3 plus 5. That is the only way to get to a sum of 8. Shit. Okay, we will suppose that we will not have repeated numbers in this series. But no, that would be wrong. That would be wrong because an X is suitable if and only if we can construct. Okay, the basis on which we are judging this sequence is X, and that is a privilege. I used to do that in my last year. I miss those days. Shit, they are never coming back. Hate to break it to you. Yes. Okay, the only metric on which we are differentiating these values from each other is X. And the things which we are changing to get the exact same values for the area. And shit, I'm being very, very vague, and these statements are only making sense to me, but okay, my bad. But yeah, to get the same value of X, the area, we are only changing A and B. And we don't care about the A and B, we only care about if a certain X is achievable or not. So we will suppose that since there are two different ways to get up to 15, either the direct way, which would be 7, 8, 8, the 64. Yeah, 64 minus 49, that is 15. Yeah, we will suppose that it does not matter. And okay, so our final series would be every odd number greater than equal to 3. That is what our series will include. And every, you can write C into 4, where C is greater than equal to 1. And if someone asks for the ith number in this, how do we find out the ith number? Our series would be like 3. And yes, this thing has to be this. We cannot have a sum of 4. Yes, a difference of 4. 3, then 5, then 7, then 8 is the next thing. Then 9, then not 10, but 11, then 12, then 13, and 14, not possible, but 15, 16, 17, 18, not 9. 18 is also not possible. Uh, it's 19, then 20 is possible. 21, 22, 23, 24. This is the sequence, but how there are like two formulas for this part of the sequence. We do 2i plus 1, where I is at minimum 1. And for this thing, we just do this C4, C4, that is not a chess move, C4, where C is greater than 1. That is forming our series. But how do we figure out like what is the ith thing when we have two formulas guiding our series? That is kind of crazy. Maybe using binary search. If we have n equals like 10, the actual answer would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have to return 16. How do we know when n is 10, we have to return 16? I feel like binary search somehow. Okay, if we divide this whole thing into two different series, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. 23, 25, 27, and dot dot dot. This is the series where AI, the ith thing, is given by 2 into I plus 1. That is the ith thing, ith term. But then we have a different series which starts from 8, then 12, then 16, 20, 24, 28, 32, 36, 40, and dot dot dot. And here we have 4 into I, where, yeah, 4 into I plus 1 is there, because we want to start I from 1. And if we take both of these series and put them into a array and sort the whole thing, and then return the ith value. That is the thing. But since n can be as big as 10 power 9, we cannot make a array whose size is 10 power 9. That is too much. I feel like we can apply binary search somehow on this thing. What is the maximum value of n can be 10 power 9 is the maximum value of n. And how many of this can fit? Okay, shit. Okay, okay. I think we can think about this in this term. Um, Before every value in 4 in this series, we have two values from this series. Right? Before 8, we have 3 and 5. Before 12, we have 7 and 9. Before 16, we have 3 values here. Shit. Okay, I messed up. Since this series is increasing by 4, let's say we have a multiple of 4 here, x, then the next one will be included because the next one would be odd. Then the next one will not be included since it is even and not divisible by 4. But the next one will be included, x plus 3. It is odd. Every odd number is included. So for, I think we can just take remainder with 4 of this series of the number n. Shit. If our series was like natural, if this thing does not include 1, which is a shame, and this thing does not include 4, and if they did, then before the first occurrence of any number from the series, which would originally be 4, we would have 1 and 3, right? And then a number from this series. So things are increasing at a gap of 3, and then we will have 8. But before 8, another number from this series, we would have had 5 and 7. 5 and 7. So I think we would have just taken remainder. Okay, this is nice. This is nice. This is nice. I think what we can do, if n equals 1, we know the answer is 3. We can just handle that separately. And then for every other n, we want to start the series from here. That is, if n equals 2, we want that to start from here. Yes, we can do n minus minus after, if n is not equal to 1, then we can do n minus minus. And our first number would be this, second would be this, and third would be this. Okay. And then we'll take remainder of this number with 3, or not remainder, but yes, remainder, but also how many, we will divide that number with 3, and we were looking for the n equals 10. N equals 10, we will do n minus minus 9. We divide this number by 3, we get 3, and remainder is something. Then 3 plus remainder by 3, which is in this case 0. Yes, so we'll get the third value from this series. That should be 3 plus 1, 4. 4 into 4, 16, which is the actual answer. Okay, that is nice. That is nice. And right, if the remainder is 0 with this, then we will just return the, like, this value from the fourth series that we got by dividing n minus 1 divided by 3. If this thing n minus 1 is divisible by 3, then we will just return the n minus 1th value from this series. But if not, then we'll have to return some value from here. And if the remainder mod mod can either be 1 or 2, because we are taking mod with 3. So when mod is 1, then we will return. Then we will again take value, take the n minus 1th value from this bottom series, and if remainder is 1, then we need the next odd number after 4 into n. Shit, we can just directly do 4n. 4n, no, not 4n. Yeah, 4 n minus 1 divided by 3 plus 1. This number, the ith number, or n minus 1 by 3th number in the fourth series. If the remainder is 1, then we can return the next odd number, which would be this number plus 1. And if remainder is 2, then we will add plus 3. And that is nice. And adding plus 3 does not make sense, by the way. And we don't have festivals. That is another thing. And if n equals 1, long rest equals 0. If n equals 1, then rest equals 3, else n minus minus, and we will get, right, and x equals n divided by 3, which is nice. And rest equals 4 into 4 long into x plus 1 long. And if mod x in m mod equals n mod 3, if m equals 1, then rest plus or plus equals 1, increase rest by 1. Else if m equals 2, then rest plus equals 3. And yeah, again output rest. Of course this is correct. Of course this is correct. And right, let's submit. This was nice. Series and sequences. I think this would work. This would work, right? Yeah. And we almost kind of proved this thing. Yeah. And we have also taken care of long. Yeah, which is nice. Accepted. We will 40 minutes. 40 minutes is nice. This was a series question and I had no idea how to do this. So that was nice. This was nice. Let's read the editorial. Series. Okay, so what was the main thing? We had, so yeah, if we subtract everything else, and we just look at the mathematics, it turned out that we have a series of numbers, and generally there is a formula for the ith number in a series. F takes an I and gives out the ith number. But this series that we had is made up of two different formulas, F dash I and F double dash I. So yeah, we had two different formulas, and let's say F dash dash I equals this one of the formulas takes in 2 into I plus 1. That is, yeah, this one, this is the one of the formulas, and the other one is F double dash I equals 4 into I. That is the other formula, not 4 into I plus 1. And our series was based off of this formula, and we had no way to figure out the ith number in this given series, which has two different series merged into each other. One series comes out of this formula and one series comes out of this formula when we increase the value of I, and we have merged these two series in ascending order, in ascending order, in sorted form. And the problem, yes, and the problem, or not the problem, but the nice thing about this series is both of these are AP, arithmetic progression, and therefore the intervals in which patterns are being repeated is fixed and the interval is not increasing. And yes, so what that means is that you would have at the start two terms from this series, and then one term from this series, then two terms from this series, and one term from this series. What that means is from this series we have 1, 3, 5, all the odd numbers, 7, 9, and in this series we have 4, and forget about like more specific parts, because this here, if you put I equals 1, you will get 3 and not 1, but bear with me for now. And then 8, 12, 16. So the general trend is two numbers from the series, 1, 3, then one number from the series, then two numbers from the series, 5 and 7, then one number from the series, 8, then two numbers from the series, 7, 9, then one number from here, 12. 12. And all of these are in ascending order. So that is nice. Since the interval was not changing, the interval where the pattern repeats is 3, 2 plus 1, 3. So we can just look up the pattern and figure out the formula, figure out the ith number in the combined series. But I'm thinking, but here the length of the repeating pattern was fixed. But if the length was also increasing, like one of these formulas, let's suppose, was a GP and not an AP, in that case, I guess we would use something similar to binary search to figure out exactly what we are looking at. G, garbage, okay. This was comp fest or something. G, garbage. Let's go with that. That is part of it. I saw brute force sitting somewhere. Let's see with the bottom side of the right triangle, the side that is not A or B from Pythagoras theorem. We know this. So C square equals B square minus A square. We can see that the area of the square at the bottom is C square. So an integer is suitable if and only if it can be expressed as B square minus A square for some positive integer A and B. Consider the case when B is 1 greater than A. Right, so we can write B as A plus 1 whole square and A square plus 2A square plus 1, that will be just 2A plus 1. Since A must be a positive integer, then all possible results for this case are all odd numbers that are greater than or equal to 3. Consider the case if B is A plus 2, then b square minus a square equals this thing, and 4a plus 4. Since a must be a positive integer, then the minimum answer in this case is 4 and in is 8. That is nice. Let's consider an integer that has a remainder of 2 when divided by 4. We can get that such an integer can never be expressed as a square minus b square. This is because of the fact that any square number when divided by when divided by 4 must have a remainder of 0 or 1. Using a simple brute force, we can get that 1 and 4 cannot be expressed as b square minus a square, because yes, using all of the information above, we can see that all suitable numbers are only all odd integers greater than or equal to 3, and all integers that are that are multiples of 4 that are greater than or equal to 8. That is true. In order to find the nth smallest integer number, we can do a binary search on a value d. In each iteration of the binary search, we check whether there are at least n suitable numbers that are less than or equal to t. Alternatively, we can use a mathematical formula, which we did use. Okay, I wouldn't know how we can apply a binary search. In order to find the nth suitable number, we can do a binary search on a value d. We can suppose what the value would be. In each iteration of the binary search, we check whether there are at least n suitable numbers that are less than or equal to d. Yes, okay, yes, makes sense, we can do that. We can, we could also have done this using binary search. And shit, I closed Excalibur, and we'll do another question. Let's do fault and tolerant network. Could be graph. Let's see, whatever it is. Okay, cool. There is a classroom with two rows of computers. There are n computers in each row, and each computer has its own grade. With two rows of computers, there are n computers in each row, and each computer has its own grade. Computers in the first row have grades this one, A1 to AN, and in B1 to BN. Initially, all the pairs of neighboring computers in each row are connected by wires I to I plus 1 in all the neighboring computers, okay, in each row. So, two rows form two independent computer networks, which are connected in series. Your task is to combine them into one common network by connecting one or more pairs of computers from different rows. Connecting the ith computer from the first row and the jth computer from the second row costs AI minus BI absolute difference. So you can connect one computer to several other computers, but you need to provide at least basic fault tolerance. You need to connect computers in such a way that the network stays connected despite one of its computers failing. In other words, if one computer is broken, no matter which one, the network won't split into two or more subparts. What is the minimum cost to do this? Okay, since we have a line here, and if we just have one connection, one connection, then if this computer breaks, then shit, everything from here to here is broken. Fault tolerance. You can connect one or more computers to several computers, but you need to connect computers in such a way that the network stays connected despite one of its computers failing. If one fails, okay, let's say for this computer, for this one to be connected to this one, if anyone in between fails, then yep, that is gone. The connection is gone. So what we would like to have is for this computer to reach this computer, you can connect these two ends, right? And if let's say any computer goes down, if this one goes down, then the computer that is adjacent to this is connected to from this side all the computers on the grid. So there has to be a cycle. And if any one part goes out of the cycle, then still it is fine. And okay, but that is not the big thing, I would say. Is how many dangling computers can we have here on the side? Here, this is one side. Here, this is another side. Here, this is the third side. I think we can have only one dangling computer here if wanted. So here we have uh, a range of two computers, and here also a range of two computers, and here also a range of two computers on the top right, and here also a range of two computers to choose from. Makes sense. And also, not just this, these, okay, what is the minimum number of computers that we have in anywhere? N is at least equal to 3. N is at least equal to 3. So we can just brute force. If N equals 3, then we can choose any three computers from the top, since we have three computers here, and should we don't need this here, we can make do with a single connection actually. No, we cannot. We cannot. We cannot make do with a single connection. These are connected to each other, and on here also these are connected. And if this is the only connection that we make, and if this computer breaks, then shit. And if these are the computers, and that is how they are connected, and we can have two connections anywhere we like. Yes, everything works. If this one breaks, then this is connected to every computer here and also here. And this is connected to every computer here and here. And yeah, everything is connected to everything. So we need to have a loop that is nice. And we can just brute force this answer. What do we have to output? We have to output the best answer possible. Yeah, brute force is nice here. Yeah, brute force is nice. A and B. Okay. What's the in A size n, B size n for int reference x, x and A. Yep, taking x. Yeah, really nice. And if A replaces B, we have everything. And if n equals 3, right? And here we say long response initially equals 0. And if and we'll have two different vectors which say which numbers are possible 1, yeah, and possible 2. If n is 3, then pos 1 equals a and pos 2 equals b. Else, and pos 1 dot insert pos 1 dot back. At the back of back does not mean anything. N insert value, or you can just do pos 1 dot push back a 0, 0, 1, and Here n minus 2 and n minus 1. Instead, we will have like 4 different loops inside. Substitute pause 1 with pause 2, and in the same range, substitute a bracket a with bracket b. Cool. Yep, that is nice. And now we will have 4 loop, which is crazy. Int I equals 0 and I less than pause 1 dot size, or in, let's say, x equals, or in size equals pause 1 dot size, because size could be equal to 3 or it could be equal to 4. dt this thing and size, okay, and then I plus plus for int j equals 0, j less than size, and j plus plus, and I and j are indices of 2 different things from a from a, and the thing would be equal to int max, and j would be equal to I plus 1, uh, I plus 1. Right, and here we can take x and y. For int x equals 0, x is smaller than sz, yes, and x plus plus xz minus 1, or yeah, xz minus 1, here also I less than xz minus 1, and for int y equals x plus 1 and y smaller than size, and y plus plus, yes, 4 nested loops, which is kind of crazy cool. And we can choose now res equal minimum of current value of res, or absolute. There are 2 ways. Either we can pair up I with x and j with y, or we can pair up I with y and j with x. So we'll do both. Res equals minimum of current value of res, or pause 1 I absolute value, absolute difference of pause 1 I minus pause 1 x plus absolute value of pause 1 I j minus pause 2 I x, replace with 2, res equals minimum of res and absolute value of pause 1 I. Now we are pairing up I with x y, and plus absolute value of pause I pause 1 j minus pause 2 x x. This makes more sense, and yeah, that's mm, this is long long and the other ones are not long long. That seems to be the position mistake. If we can change and make this thing long. Okay, shit. Pause 1 equals I equals A. Doesn't seem to be a valid index. Okay, because those two are in. So it's split into a long, long. Okay, 13 is what they say. How is 13 possible? In the first one, minimum of this and absolute value. I guess we mess up in initializing these two values. Equals A. Size is equal to N. How can this difference be equal to 13? 13 does not make sense. I plus 1 and Y is X plus 1, which is nice. So they are not never overlapping. Plus 1 dot size. That is nice. Second answer is correct, but the first one is wrong. Let's see. 13, oh, shit, it has been 13 from the start. How? 9. Pos 2 equals B. I guess we messed up somewhere. See out pos 1. Yes, and pos 2. Let's debug. 110. Okay. The values are correct, but why are we misbehaving in the answer part? I initially equals 0 and j equals 1, which is I plus 1. And okay, we can pair up this number with this number. Yes, in which case 90 plus 6. Wait, absolute value. We are getting the absolute value. Initial value of response is something. Is this not returning a positive value? Is an absolute block. Okay, first thing did say 25. Then we paired up 1 with 4. The difference is 13. It's 3, and then this with this, which is nice. Okay, so why does this thing fail? This is the pairing that we have done. And let's say this computer fails. This computer fails, then everything is still connected. This connected to this, connected to this, connected to this. Right, so 4 pairs computer 1 from the first row with computer 2 from the second row. 3, yes, and second computer 3 from the first row, computer 3 from the first row, yeah, computer 3 from the first row, this one with computer 2 from the second row again. So yeah, this, and both are connected to this one computer. Okay, yes, we didn't consider that possibility. Shit. Yes, we didn't consider that possibility. But wait, that would be not very good. Computer 2 from row 1 from the first row, this 10 with computer 1 from the second row. This one 10 and 20. Difference is 10, right? But we could just pair up the computers in this manner. This one has a value of 1, then 10, and then 1. And this one has value 20, then 4, and then this one has some value 25. This is the pairing that we have done, and the pairing that they have done doesn't seem to be very nice. So why are they doing this many pairing? In the second test case, it is optimal to connect one computer from row 1 to second, and 4 from row 2 to computer second. Why are we connecting 4 pairs of computers in this case? Is this pairing not enough? If this computer, shit, my bad. If this computer breaks, then this one is off the grid. Shit, we must choose the computers from the ends. But can we ever skip that part? Not. Okay. This is one thing that works. Okay. And our main goal is to make a circle. Circle? Yes, make a circle. Okay. This is the pairing that we did, and it is wrong. This is wrong. And the pairing that they are doing is 1, 10, 1, and 3 computers here. These are already connected in one row, and we have 24 and 25. 1 from row 1, 1 with 2, 3 with 2, 2 with 1, and 2 with 3. Yeah, 2 with 1 and 2 with 3. This is what they have done, and this is nice. They have made 4 different choices. And we do have cycles, and we have 2 cycles here. This is one cycle, this whole triangle, and then this whole triangle is another cycle. And if any one computer breaks in a cycle, that is completely fine. So what we need to have is we need to have cycles, multiple cycles. We can have multiple cycles. In this case, we have multiple cycles, and if making multiple cycles works, then we make multiple cycles. N is 10 power 5. Okay, cycle. We need to make cycles. Okay, we have a bunch of computers in the first row and a bunch of computers in the second row, same number, and they are connected within the same row itself. That is nice. And now we need to connect them and form a cycle, so that if one computer breaks from the cycle, then the whole thing doesn't come down. And if you want to make one cycle, then this is one way to make a cycle. right? So whole thing is a cycle. But okay, let's say we change, we are not connecting this computer. Let's say we connect this computer, right? So this one is off the grid, and we can fix this by connecting this. Since this whole thing is a cycle right now, we can connect this computer with anything here, and now we have a couple of cycles, which, yeah, so all of these computers are already in a cycle, and this big one, and this one is also in a cycle, and that cycle can be this. That does work. We need to figure out cycles, how to make. We don't need to minimize the number of cycles. We just need to get the best thing out of this. And the order does matter. Okay, we need to connect this computer with some computer here, and we need to connect this computer with some computer here, right? And then we need to connect this computer with some computer here, and we need to connect this computer with some computer here. That is our main objective, and if that is possible, then nice. Yes, so we just need to connect the border computers to the best one possible. Also share. Okay, I have a choice to connect these two computers directly and make this one do and this one also, and I would get, and let's say this is the best. If this is the best choice, then very nice. But if connecting this computer with this one is not the best choice, and instead connecting this one with this one is gives much less difference, like that is better, then I have this one dangling, and I still have to connect this one with something. So I have three choices, kind of. If for we take it from someone's perspective, hello, I am learning maths. Will it help me? Yes, it will help you in competitive programming. It is maths. Maths is kind of nice. I mean, yes, and not just for competitive programming, maths is nice generally speaking, and it will help you in different things. Yeah, there is no side effect in bad a bad side effect for by learning maths. So it is always a good idea. So for each edge computer, I have speaking three choices: one this one on the other end, and one here. Okay, if we connect this computer with this computer, then we won't have to connect this computer with something. We can calculate what is the best one for this, what is the best one for this, what is the best one for this, what is the best one for this. Right. And yeah, yes, right. And at maximum, we will make 4 pairs. That is the thing. And at minimum, we will have to make 2 pairs. Yes, at minimum, we will have to make 2 pairs. I think there must be some way that we can brute force this solution. 2 pairs and 3 pairs and 4 pairs. Yes, we can brute force. We can brute force. Once we can connect this computer with this one. And what would the next step be? Next, yes, then we won't have to connect this one with anything. And we have already this one connected. Then we can connect this one with the best one. Edge computers. This is networking. Shit. This whole thing is wrong. I believe that. And here, do this. Okay, shit. There has to be a brute force way to find the best matchup and to send the question on the chat, even though no one's there. This thing, yep. There has to be a way in which we can connect these. Com we can afford to brute force because we have just like 4 computers from each thing. To consider from, like, for this computer, I can choose this one, or the best one for this one, which like whatever. And then for this one, I can choose this one, or the best one from this one. Okay, okay, that is nice. So those are the computers. Those are the only computers that we will consider from this row, and the same in this case. From this row, we can choose this one, or the best choice for this one, or the best choice for this one. So we will have 4 computers from the row. Okay. I think we can, yes. So we will have 2 vectors, and in the first one, this and this computer will be there, and then the second one, this and this computer will be there. Then we will look for the best choice, the closest number to this one from this row, and the closest number for this one from this row, right? And if they happen to be same to these computers which we have already chosen, then it is fine. But if they are different, then we will have to add them into the vector of choice, right? So that is crazy. That is crazy. That is like literally crazy. How okay, we do understand the problem and what specifically we have to do, but how is the next question. These are the computers here, and in the other row, there are these computers, and these are connected already. All the computers in one row are connected. And the minimum requirement is for us to connect this computer with something, this computer with something, this computer with something, and this computer with something. Let's suppose we will make four connections. Let's suppose, yes, that we will make four connections, and then we can eliminate if any two connections are the same. Yes, we can then just eliminate if any two connections are the same. Okay. Right. And for this computer, the only viable choices are this one, and the best choice, with which this computer will give the minimum absolute value, the minimum absolute difference. And for this computer, the edge computers and this one or anyone which gives minimum value from for this computer and this here. And if we are going to make four connections, if we are going to make four connections, then okay, either we can make four connections and then eliminate two connections if possible. Let's say for this computer, the best choice is this computer. Then we will just connect these two and we won't have to connect this one to anything. Yep, we won't have to connect this one with anything. And let's say for this one, this is the best choice. But we are saying that for this one, the best choice is this, and for this one, the best choice is this. How can we eliminate these green arrows? To eliminate these green arrows, we can see that this computer would be appearing in one of the pairs or in two of the pairs, and one of the numbers in that pair is the edge computer. So like this one is just extra. We can remove this, or we can look from this computer's perspective and we can see that all of these are connected to different computers. And yes, yes, and this are connected to the same computer. So we will revoke this connection, but that is just kind of like moving in circles. I guess the yeah screen is visible. That means it's cool. Shit. Okay. I think yes. I think we can look at the editorial for this because we have already spent 37 minutes, but that is not the main thing. We need to figure out a method, even though we understand the problem and we know what we want, we just don't know how. We can do that. Yeah. And since I don't seem to be having any ideas, it is okay to look at the editorial. This is educational round. Educational round. Educational rounds are nice. Question number C in an educational round. Nice. There is a criteria when the given network becomes fault tolerant. The network becomes fault tolerant if and only if each of the corner parameters, that let's name them, A1 to AN and B1 and BN are connected to the other row. Yes. From one side, if W log A1 is not connected to the other row, okay, we don't need the proof on this. From the other side, suppose W log AI is broken, then the row A is falling into at most two parts, A1 to AI minus 1 and A1 plus 1 to AN. But since A1 and AN are connected into row B and B is still connected, then the resulting network is still connected. Now the question is how to connect all the corner computers, because sometimes it is optimal not to connect the corners directly. One of the approaches described below. Yes. Let's look at A1. Essentially, there are three ways to connect to the B1, BN, or the best possible choice. Yes, for A1, where best AI is some BJ with the minimum possible value. This the same applies to AN. Okay, so let's just iterate over 3 by 3 variants for each of these variants. For each of these variants, if we didn't cover B1, then we would add one more connection between B1 and best B1. And if we didn't cover B, and then we should also add one more connection between BN and the best A1. 3 by 3 variants. What does this mean? 3 by 3 variants. AD, Adidalic, Adidalic. Let's look at A1. Essentially, there are three choices for A1 and okay, same for B1. So let's just iterate over all these 3 by 3 variants. Okay, yeah, what does that mean? Okay, that is long debug. If define debug, then f open input.txt or read from a standard input into input.txt. Best candidate should, yes, makes sense. We can just iterate for best candidate. Infinity is infinity plus 10. That is fine. Infinity plus 10. Yeah. Vectors a and b and n, and do read. What is read? If not c n into n, return false. And a dot resize will be equal to n, and for entire into a, okay, and for, okay, reading a and b, cool, calculating the best variant, best read and then solve, okay, and then solve, okay. Best right now is 10 into long multiplied by infinity, okay, and then vector integer cds1 equals best candidate a vector cds1, 0 is one value, then best candidate for a0, nb, and then n minus 1. Indices, okay, and this thing also returns index, makes sense. The first thing and the last thing and the best. Okay, one and this and this and okay, okay. long integer. Answer is long integer absolute value of A0 with B variant. Okay, we are okay. 1 and 2, depending on which one is better. Variant 1, if both of them are greater than 0, which means we didn't use the first one. Okay, this makes sense. We can do this. We can do this. But how do you say that this will work? Are you a student? And yes, which university? Hello, I am in EKT University, fifth semester. Yep, I will keep it up. Thank you for that. Rachit Chauhan, 1938. If you were born in 1938, that is very old. Shit. And thank you. You too. Best of luck. Do your best. Why does this thing work? Why does this thing work? We are saying that we first try to, for this computer, there are like just three possible choices. This one, this corner, this corner, and the best choice for this, whatever it is, whatever it happens to be. Right. And then for this computer, there is this, the best choice for this, and the other corner. Okay, this does make sense, but only in the periphery and not in like specifically why would this be true? And I can implement this right now. Let's do implement this. Choices, vector in CH, choices for A1, or choices for one is nice, choices for one consist of 0 and n minus 1, and the best choice in B1, best choice would be 0, and then we can iterate for we, which we should write a function instead, a function which returns integer and takes in a vector of integers reference, let's call it x, and an integer x. Okay, we cannot name same thing twice. Integer, let's say n, and then for int I equals 0, I less than n, I plus plus, and int bs equals 0. Bs plus means best, and if going with bs, if we do go with bs, then we will have bs, absolute difference between x bs minus n. If this value is smaller than absolute difference between xi, the current value, and n, then we will say best value is I. And at the end, return yes, the best value. Right. And for C1, there are three possible choices. The first computer, last computer, and the best computer for it. Nope. EKTU is the main university is in Lucknow, but I am in Meerut. Yeah, so yes, there. Best from B when we are going with A0, and vector in, or we could just say here CH2 choice 2 for 0 and n minus 1, and best in B comma A n minus 1 A dot back. That is nice. And we'll say long answer equals the maximum possible value in max multiplied by, let's say 10 long, that would be long enough. And then for in I, or I in choice 1, and for in j in choice 2. and long C answer, like current answer, will be equal to absolute difference between A0 minus, yes, absolute difference between A0 and BI plus absolute difference between A n minus 1 minus Bj. Makes sense, right? And the choices which we have made in B are I and J. And if I and J, if both of them are non-zero, then B0 was left, right? B0 was left. Then we will have to add to C answer plus equals absolute value when we take B0 with B0 with best value for B. That would be minus in A, best value in A comma B0. And if I smaller than n and j also smaller than n, then we have not chosen the last value in B, so we have to choose that. Answer equals plus equals absolute value in B and minus 1, the last value in B, minus A, best all that is A and B and minus 1, last value. And answer equals minimum of answer and C answer. See out answer semantics makes sense. Substitute int with long globally. Okay, and application binary interface. Shit. Side is s dot side. Okay. Shit, that was kind of bad. And shit, that is even worse. Even worse than before. Shit, that is bad. We are looking for a smaller value. Okay, we are getting wrong answer in the second one, and the answer is off by 1000 and something. And minus 1 be best in A last. Answer long. BI and BJ A best in A with B0 and best in vector A with Bn minus 1. And minimum of answer and C answer. Huh. Should this should be working, but it is not. Let's see what is the current answer. Okay, that is a lot of answers. And yes, here we did have 31 at some point, which is nice, kind of. But here we are never getting this answer, which would be when we are connecting this thing with this thing and this thing with this thing, and why is that not happening? Okay, that is why. Cool. Yeah, now it works, and that is cool. That was cool. Let's rewrite before submitting, which is a nice thing. In n, take in n, yep, vector long or integer would work in A and B, both have n values, and then for in reference x in A, take in x and copy paste, find A, replace with B, and yes, now we have to make another new vectors, choices for one and choices for one, which would be 0 and minus 1, and the best choice for the first element for the first element in vectors A, for which this thing will take in a vector of integers reference, we will call it x, and another number and an integer I is I, no, not I, we will call it C, and then in for in I equals 0, I less than x dot size and I plus plus, and we will also have in bs as in the best choice, where we are only taking the index of the best choice, and if yes, yes, absolute value of best choice from x bs minus c, and this thing is greater than the current choice, which will be xi minus c. If that is the case, then we will say best choice is I instead. And again, we will return bs, the best choice. And for the first value in A, which is A0, the only possible choices are 0 and minus 1, and best value in B for A0. And then CH2 choices in 2 would be same, except the best choice is now for the last value in A. And long answer is in max multiplied by 5 long, right? That is fine. Yeah, 5 long is very nice. 6 would also work. And now for in I in choices for 1 and for in J small in choices for 2 and long C answer, current answer would be absolute difference between A0 minus the choice for A0, which will be I, plus absolute difference of A n minus 1 minus choice NB for the last value in A. And if both of them are non-zero, which means we have skipped the first thing from B. Therefore, yes, we will have to increase our answer by taking the absolute difference between B 0, the first value in B, minus the best choice for B in A, where B0 is the number, and this best function returns index in A. So we will do give the this thing into A. And if I is smaller than n minus 1 and j is also smaller than n minus 1, which means we haven't chosen the last value in B, therefore we have to increase our answer. That's equals absolute value in B n minus 1 minus B minus A best choice. Shit, that is not how you call a function. You call a function with parentheses, not this stuff. Right, right. And here we will pass in A and B n minus 1. And update answer. Answer equals minimum of answer, comma, C answer, current answer. And at the end, we will output answer, which is very nice and it works. Okay, let's submit. This was nice. This was nice. We had to read the editorial, but this was nice. This was a nice question. We were able to figure this out, like what we need to do after reading the question, but the thing where I struggled was how to implement the thing, like how to do, how to find out what we want to find out. Okay, this is still running, and I don't expect this to be wrong. With that took a lot of time. That did take a lot of time, and I think we can save that time by saying B0 equals best A comma B0, and in B n equals best n A comma B n minus 1. And instead of calling the best function here, we can say B0. And instead of calling the best function here, we can say Bn. And let's resubmit and compare the time. This was nice. This method was nice. And I would have to review this. This was nice. And I expect this method to be like faster than the last one. And it is not faster than the last one. It is actually taking more time. Sure. Fine. That is fine. It means we can stop the timer. And that is nice. We have done 2 questions, which is just 2 questions. Let's do a few more questions. Divan and Vitais. There was a XOR question, even, odd, XOR. Let's do that. We have done garbage or array, knowledge cards. That is nice. That is nice. And how many questions have I done in this 1500 rating? Break free. Yes, I want to break free. Shit. Okay, 59. That is quite a bit. Yeah. I guess I will give the next contest. That would be nice. Stopwatch. Cool. And I will go to the washroom and I will be right back in a minute. Then we will do more questions. And it has been 2 hours and 4 minutes. So let's do 2 more questions. And I'll be right back in a minute. And me is back. And more questions. Let's go. Given an integer n, find an array A of n distinct non-negative integers smaller than this, such that distinct bitwise XOR of same numbers is equal to 0 of the elements is an odd indices equals the bitwise XOR of elements on the even indices. Given a size, n is at minimum equal to 3. That is nice. When n equals 3, we want the bitwise XOR to be equal. And the numbers must be distinct. Let's say we use 1 and 2 and not just distinct, non-negative. So we can use 0. So 3 and 0, this works. Yes, this works. This works. And if n is 4, then we just need to add two numbers. N equals 4 is not going to work. N equals 4 is not going to work. N equals 4 should work. Okay, this depends if n is a multiple of 4 or not. If n is a multiple of 4 or not. For n equals 4, what can the solution be? We can choose a 0. We need 3 numbers at one place whose OR we will take, and two different numbers. Two different numbers, and yeah, let's say we are using these bytes, and the numbers are between 0 to 7. For 0, 0 doesn't have any effect on anything. If we take 1 and 3 at one location, okay, yes, we can take 3 and 1 here, and here we can no 3 and 1 will just mean 1 0, which is 2. Yeah, which is 2, and yeah, which is not going to work very well. 5 is 101. Okay, so instead of 3 here, we could have taken 5 or 1 is 4, but can we make this thing equal to 4? Can we make this or equal to 4? We can, if we take XOR with 5 and 1, yes, but if we take XOR of 7, which is 111, and we want to remove these two things, we can just take XOR of 7, XOR 2, XOR 1, but shit, we have already used 1, so we can avoid using 1 by taking XOR of 0 and 4. Okay, yes. So this thing works 1, 2, 1, 0, 4, and 7. This is a valid sequence for size when size is equal to 5. So that is nice, and this is the current question that we are doing. 10429, and if we here take XOR of this, and this, we will get 4, and we take XOR of this, and this, we will also get 4. So that is nice. Okay, since 2 power 32 is the highest number we can take. This means that there are in total 32 bits that we can manipulate. Yeah, 32 bits. And what is the maximum value of this? It is 10 power 5 and 10 power 5. 10 power 5 is one with, like, yes, 10 power 5 and 2 power 32. 2 power 32 is like 2 billion, which is 2 into 10 power 9. So we will not run out of numbers. That is nice. And we have at max 32 bits. We have at max 32 bits. So for each bit, we can decide, do we want that bit in the final answer or do we not want that bit in the final answer? And depending on n, we can have the bit and also we cannot have the bit. If n is even, then there are going to be even numbers. And if, let's say, we separate the numbers which are appearing on even indices from the numbers which are appearing on odd indices, and let's suppose that n is even, therefore this count is equal to this count. The numbers, yeah, even numbers at even indices and the numbers at odd indices, they are same, the size same. Hello, good morning. How is everything going? Check out this question. What Mac you use? M1, basic M1 Mac. And have you heard Freebird song by Lynyrd Skynyrd? That is a nice song. That is a nice song. A very nice song. Freebird. Even indices and odd indices, and for a bit to be on at the end. Yes, yes, that is nice. Hello. How is everything going on? Okay, let's forget that we have two things. Let's suppose that we have just one set of elements that we can choose from, and we have 32 bits that you want to, that we can keep on or off. And if number is n is even, then we can turn off all the bits after taking this off. What question? This one right here. So your laptop on Google. What do you mean? You can look up MacBook and one, this thing. Should, this is not certainly, this is M1 Max. Mine is like the base model. This one. Wait, this is not even that. This one. Yes. Shit. Why is this so cheap right now? 35,000. Yes, that is the one. That is the one I'm using. Cashify. It is Cashify. So refurbished, pre-owned, pre-owned. Yes, it is now very cheap. So, and also a very good laptop. And this is the one on which I'm streaming right now. So yeah, it is good. If n is even, we cannot, if n is even, we do have the choice to have some bits on at the end and some bits off. Let's say we say that n equals 6, and for 6 we want, let's say we are only working with 5 bits, and for n equals 6 we want to find numbers, 6 numbers, for which if we take XOR, we get this as the final output. Yeah, so yeah, we'll have to use, let's say, one of the numbers is exactly this. And all the other numbers, we're gonna start choosing them from bottom up. Yep, the smallest. And now there are four numbers left. Yes, now there are five numbers left. Yep, that one. NVM. I will read it. Saw your link now. Yes, right there. There are five numbers left. And what can we do? We have already, I think this choice, choosing this one number is not good. We can start from the top. Yes, we can start from the top where all the bits are on. Yes, let's say yes. Shit, yes, okay. We can start from the top. N equals 6. We need six numbers, and we are considering for now just five bits. And the final answer has all the bits on. And we need to choose six distinct integers. Even indices or equals odd indices. Yep, that is the thing. And yes, right now I'm trying to see, given a certain like final XOR, can I figure out some distinct numbers which give me that XOR? Yeah, which give me that XOR. And if n is 6 and I want to have this number as my final number, then one of the numbers that I can choose is this. And since I want these bits to be on at the end, then the number of counts for like out of n numbers, an odd number of bits should have this thing on and should have this thing on. This should have this thing on, this thing, and this thing on. If n is even, we can choose this number as one of the numbers, right? And this is 1. This is one of the numbers. Let's say the first number. Now second. Now we have to choose second number, third number, fourth number, fifth, sixth, and the count of these bits must be even. So for 2, 2 will be like exactly equal to 1 except for the last bit, let's say 0, and this bit minus 1. What we want is the XOR of all of these numbers to be equal to 0. XOR of these numbers to be equal to 0. That is a very strange number, 629. The condition in the question, it means that every number less than 231. Let's say if you have two different numbers, 10 and 1, the XOR is, oh, and not 10 and 1, 1, 0 and 0, 1. The XOR is 11. So you can achieve the same by appending a 1 to the left of these numbers. This is also 1, 1. Yes. And I have two different numbers which give me the same XOR. So that is nice. I can make one of the lists and I will not include 0 in the list. I can make, I can choose all the numbers at the even index, and if the numbers at the odd index are same, and the count of odd numbers is same as the even numbers, or the numbers at the even index, then I can just append 1 at the start. And so yes, so the numbers at even indices, their list is also ready. But if there is one more number at the odd index, then we can choose that number as 0. 0 works. It will not change. Okay, so the same. Shit. Okay, okay. So the final sort does not even matter. We can start choosing numbers from 1. Okay, shit. Okay. If shit. Okay, if n equals the smallest value for n is equal to 3. Yes. We'll first make our list of even numbers and we'll say 1 is our only even number. Even list, even list will only have one number, and odd list will have two numbers. Let's say we will start filling the even list by starting from 1, 2, 3, 4, dot, 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 till later on, right? And for odd list, we will take the first number from even list and left shift, not left shift, add 1 here to, to that number. Yes, add 1 here to that number. So this would be 1, 1. And here we will have 0. And that is completely wrong. Shit, that is wrong. Just keep picking pairs of even and odd numbers, then keep adding 1 to them. You can pick, uh, you just keep picking pairs of even numbers and odd numbers, then keep appending 1 to them. There is, I mean, we can at max have 3 of them. Okay, this is the only case. N equals 3 is the only special case. Otherwise, for n equals 4, we can choose the even list as 1 and 2. And for the odd list, we just append 1 to each one of these at the same index. Should this works? This works out in odd. Yeah. So if in odd place we have one extra number, we can make it equal to 0. Yes, and then we will have same number of numbers in even list and in odd list. And then in odd list, if the count, or like the count of numbers in even and odd list would be same, but if the count is even, then for each even number, to make a corresponding odd number at the odd index, we can add 2 power 31 to that number, which just adds a 1, like right here, whatever the number on the right is. That is nice. But if the count is odd, then we will still add 1 to all of the numbers. We will still add on. No, no. Yes, if the count is 1, then after adding this thing to all of the numbers in the odd list, We want the highest bit to be on. XOR will be before him. I think we can decide the XOR will be 1. Idea good. Yeah, in the odd list, XOR is 1, and in even, it is 1 XOR. Okay, I don't get this. You can pick a number up to this, and limit for n is, yes, this. So much greater than this. So I think this approach should work. Adding one at the start does work. We can make the even list, and for the odd list, we can add ones at like one at any place we want for each of the numbers. If like the even list turns out to be something like, by even list I mean the numbers and even indices. If it turns out to be in binary format, 0 1 1 0 1 1, whatever it is, it can be anything. And for the odd list, we can just copy this and add 1 at the same place for all of the numbers here. But the problem is if this count here, the count is 3. There are 3 numbers. Therefore, this extra bit which we have added here, this bit will remain in the final XOR, but here this will not remain. Don't worry. If the XOR is 0, in the even list, it is 1. In the odd list, we have one dangling extra 1, and we need to eliminate this. We need to eliminate this. And this should also work when we have just one element in the even list, like let's say 1, and in the odd list, we need to choose one element. I think it is not even possible to do this when n equals 3. When n equals 3, in our even list, we just have one number, 1, and in our odd list, one of the numbers would be 0. So shit, yes, this is not possible because we want the numbers to be distinct from each other. So using 0 is not a good idea. Even yes, using 0 here. Shit, 1 0 or 1 1, and here we can have 1 0. Yes, that extra bit is now off. Oh shit, yes. Yes. So our answer would be here 1 1 3 1 and 2. XOR of 3 and 2 is 1. That is nice. Okay, shit, yes. Thank you for this thing. This was a nice insight. XOR is 1 1. You can achieve the same by just yes, I didn't think about binary operations in this sense. So this is nice. This is like a new thing. That is nice. That is good. Thank you for this. And we can do this now. Yes. We'll make the even list. And we do have test cases. We do have test cases. Okay. Yes. Now, first of all, we'll make the even list. Vector n even size would be n by 2, non-conditional, and odd size would be n by 2 plus n. Yeah. Now, for n I equals or iota even dot begin and even dot n start adding numbers from them. That is nice. And for in I equals 0, I less than or dot size I plus plus, not or dot size, but even, even dot size. Yes, even dot size. Uh-huh. Or I would be equal to even I plus, yeah, say constant buffer of offset equals 1 left shifted by 30. That is very much within the range. Yes, that is very much within the range. Even plus, not even plus. Let's do or, because or with offset, right? So everything in odd is fixed, and if size of odd, if n was odd, then everything is okay. What if n is 6? Yes, now if n is odd, then we have a 0, right? And okay, if n is odd, right, then we have one extra element in the odd list. Yes, then we have one extra element in the odd list. And what we need to do is, if the size of, yes, if even dot, if n is odd, like 7, 5, 5 is odd, but 5 by 2, 2, that is nice. But yeah, 7 by 2, 3, 3 is not nice. Yes. If size of even is odd, then odd dot back, odd dot odd, odd dot size minus 1 equals offset, and else it is equal to 0. Else, if there is no extra padding, now if even dot size is odd, sure. Here instead of this, we can say the XOR with off for the last number. If the last number is already 0, then this will become the offset. But if the last number is non-zero something, and we have already taken off or with the offset, then taking XOR will turn that bit off, and we have already used that number in the even list. So that is already nice. Shit, that is not very nice. I think the core idea would work that if you keep adding 1 to the left. Damn, I'm proud that I was able to. Of course, you were able to help. Why are you being proud? Odd dot size minus 1 and offset. Shit, there's just this one little mistake that is if this would arise when n equals 6. Yeah, when n equals 6 in our odd number list, we would have 1, 2, and 3. And in our even in our even number list, this is what we will have. And in our odd number list, let's say we added the bit at position this is 8 at the eighth position. So every number would be increased by 8. So this 10 and 11. And since this extra bit would be on, since the size of this thing is odd, we want to reduce this bit from one of the numbers. And we haven't used 6, we haven't used 0. We might be able to use 0 in here somewhere. We might be able to use 0 in here somewhere. The main thing is we need to remove this highest bit from one of these numbers. I think we can make this number equal to 0. And shit, what are we doing? We are taking XOR. Okay, that is fine. That is fine. Shit. For a minute, I thought we are taking OR and everything fell apart. We can make one of these numbers equal to 0. And that will not work. Yeah, yes, this number is equal to 9. And we need to turn off this bit because we don't want this bit to be in the final answer, in the final analysis. We need to turn off this bit. And this is only this problem only exists when n is even and n by 2 is n is even and n by 2 is odd. That is n is only divisible by 1 when n is not divisible by 4 and n is only divisible by 2. That would also be a problem when n equals 5 and yes, 5, 14 and 18. We need to turn off this highest bit here, but we cannot just turn it off because if we turn the highest bit here and 11, it will become 3, which we have already used here. Yes, which we have already used here. When Wait, we just need to turn off this highest bit somehow, and everything would be nice. Yep, extremely nice. 9, 10, 3, 9, 10. This number would be equal to 11, and we cannot just turn that bit on in any of the numbers in the even list, because that would make that number equal to one of the numbers in the odd list. Okay. Since 6 is the smallest number in which this problem arises, what we can do is we can turn this bit on. Shit, no, no, no. So it still not work, because whenever we change a bit here, we have to change the bit here also to keep the difference. Shit, that is crazy. And yep, this is the question if someone wants to see. N equals 6 and bar 2, 6 is the smallest number. So what would be the answer, like actual nice answer for n equals 6? We did write the answer for n equals 6 at some point. No, we didn't. No, we didn't. For n equals 6, what would the actual nice answer be when n equals 6? Not 67. For n equals 6, let's say we start with 0, then some number would come here, and then another number 1, some number would come here, then space 2, some number would come here, and then space 1. Yeah, that is kind of it. And since the final XOR of this number is these three numbers is 1 XOR 2, which is 1 1. Yeah, 3 is the final XOR of this number, of these three numbers. Then what are other three numbers we can choose to have a XOR of 3? 101 and 110. Yes, these are the three numbers we can choose to have a XOR of 3, but we have to choose three numbers. We have to choose three numbers to have a XOR like this. Yeah, we have to choose three numbers. And 0 is making the problem. If we start numbers with 1, 2, and 3, if we take the XOR of this number, XOR is 0. XOR is 0. What is the XOR of 4 and 5? Whatever. XOR is 0. So we need to. Yes. So 0 is not going to help here. If we, yeah. Now we need to choose three different numbers who have a XOR of 0. And if we are putting one at the like eighth position, then for 1, 2, and 3, the corresponding numbers we can choose is 9, 10, and 11. Since we added this one bit at the fourth position, the numbers became this. But the problem is now we have in the final XOR of these second numbers a 1, a extra 1, which you don't want to have. I think if we do 1, 2, 3, and in the XOR list 4, in the even odd list 1, 2, 3, 4, 5. XOR of this thing is 0. XOR of this thing would be 1, 0, 0, 1, 0, 1, 0, 1. Right, and if we have the freedom to change the last two numbers in the odd list, yes, we have the freedom to change the last two numbers in the odd list. We want their XOR to equal to 0. We cannot have a XOR of equal to 0. No, we want their XOR to be equal to 1, 0, 0. Can we have two numbers whose XOR is 1, 0, 0? Um, yes, we want the XOR. How did we get to this conclusion? We took the XOR of this whole list and compared and took the XOR of that number with these two num this number with the XOR of the whole list an odd list till now, and we want two numbers to have a XOR of this. We want two numbers to have a XOR of this. One of the numbers, one of the numbers can be this number exactly, and the other one could be 0. 1, 0, 0, and we can take a bunch of zeros and put one here and take a bunch of zeros and shit, yes. And okay, shit. This is done. This is done. When n equals 3 in the even list, we will have just one number and final result would be 1. And we want two numbers to have a result of 1. We can take 1 and 0 and then add the offset. Offset is 1 left shifted by 3 to this. And thus, since we have only chosen number which are very, very smaller than this, so both of these numbers would be different than all the numbers that we have chosen till now. Cool. Yes. Shit. Shit. Okay. Yes. Cool. Shit. So in the even list iota, use the iota function and do this. And on the odd list, also apply the you don't even need to have two even and odd lists for n I equals 0, I less than, for n I equals 1, I less than equal to, we just need to save three elements at the last, I less than n minus 2 and I plus plus. And we have n I equals 1, right here, and this will be nothing, right? And see out I with a space, right? And we will have 10 even XOR equals 0. And if if not I is 1, if I is not odd, then we will take even XOR with I, even XOR with I. Right, now we have a number, and the next number would be smaller than this, smaller, smaller, yes. And even XOR plus plus, even XOR with I plus 1. And now, yes, now the next number would be number from the odd list, which is like exactly equal to even XOR plus offset, then a little space, and then I, the next even number, then a space, then the offset itself. Shit, that is very nice. That is extremely nice. That does work. That does work. That is 1 billion. Shit, that is nice. That is nice. That is nice. That is nice. That does work. Okay, this should work. This should work. And yes, this should work. This should work. I do not expect this to fail. Uh, Fail on test case one would be hilarious in some sense. Shit, why is this wrong? This is not wrong. Wrong answer. Answer not valid because the offset is too big. Non-negative integers smaller than would be nice. Offset was too big. My bad. When we do one left shift by some number x, we have 2 raised to the power of x plus 1. And since we want the number to be less than 2 power 31. So that was stupid. That was stupid. Yes, I am live saying shit is fun. Yeah, shit is fun. Invalid answer for test case 1. Should they also have something similar? Now, how can this be wrong? I don't get this. The XOR of all the numbers. Shit. Um, okay, shit. Okay, okay, okay. My bad. Let me fix that real quick. Macros, screen capture, hide OBS. Yes, hide OBS. Very personal. Okay. And now it is working. Thank you for pointing that out. And it's something wrong. Now it is fixed. But no, shit. The more important thing is it's still wrong. But I don't get why this is wrong. It's minus 2. Okay. We start from 1 and we want a XOR of 1. We take that is the XOR that. Shit, yes. We also want the XOR of all the odd XOR equals XOR with I. This is the final XOR of all the things, and then we will say odd XOR, XOR with even XOR. I know. Yeah, and odd XOR. That is the XOR that we want. That is the XOR that we want, and take the XOR. Submit. Yes, without checking if this is correct or not, we'll submit. Yo, let's go. Well, this will work. This will work. This will work. The mistake was stupid, but now it is fixed. And this should this literally should have worked. Yes. Less than 2 power 21, 2 power 21. Makes sense. Say, okay, that was also stupid. That was also stupid. But now, at least, let's see if it compiles. Okay, yes, at least it's compiling. And now it will work. Because when we exit, yes, wrong answer. Very sad. Shit. Water. There is something fundamentally wrong. XOR of all the numbers in the even list. Yes, very sad. XOR of all the numbers in the event list is the target, and what we have right now is XOR of all the numbers in the odd list. So with which number should we take XOR odd and XOR even? These two numbers are different and we need to make them equal by doing XOR with some number C, and this should become equal to XOR of E, and this number C, I am saying C would be equal to XE XOR XO. Yes, and so how can this be wrong? Compile one test case n equals 3. This one, okay. If we take I is 1, 1 and was equal to 1, and was equal to 3 and minus 2, 1, 1. We won't go into this loop. So even and odd, even and odd both are equal to 0, and even odd becomes equal to 1. So 1, we see 1 there, and then odd XOR also becomes equal to 1. We add an offset to 1. So the odd even number is 0, 0, 1, and here we have an offset. Let's say offset is 1, 0, 0. We add 1 to this offset, so this number becomes 1, 0, 0, and this number becomes 1, 0, 0. And what is wrong with this? If we take XOR of this and this, we will get 0, 0, 1. And if we here we just have one number 0, 0, 1. So equal. And that should hold for no matter how big the thing turns out to be. Test case 4. Okay, at least we are getting some indication of the 4. This one, when n equals 5. When n equals 5, we say 1, 2, 3, 4, 5. We have 3 extra numbers remaining. Okay. That is fine. We have 3 extra numbers remaining. Okay, right. I should be equal to 3 at this point, and odd XOR of odd XOR of numbers at odd places is just 1, and XOR of numbers at even places is 2. Then we take XOR of this with this because we want this number to be 3. And yes, we take XOR of 1 with 3. This turns out to be 1, 0, which is 4, right? Which is 4. We need to get to 4. Current XOR is 2. So we take XOR of 4 with 2. That would be our target number, which we'll add here with the offset. And we will add the offset here. Let's say that the offset is 1, 0, 0, 0. That is the offset. And we add the offset here 1, 0, 0, 0. And the number here would be offset plus XOR of 4 and 2, which is 1, 1. Plus offset. Offset is 0, 1, 1. So 1, 0 is the number here. And we have 1, 0, 1, 1 here. And if we write the whole thing in binary, we will have 1, 1, 0, 1, 0, 1, 1, and 1, 1, 1, 0, 0, 0. Right. And they are saying this is wrong. If we take XOR of this, what is it? How? 1, 0, 1, 1. Oh, yeah. This and this. XOR of these numbers turns out to be 1, 0. And the XOR of these numbers is 0. Shit, that is wrong. Okay, I miswrote. This thing equals 1. No, this thing does equal to 1, 0. 0, 1. Okay, we messed up somewhere. 1, 2, and we have 3 places left. X of even numbers, XOR of even numbers is 2. XOR of odd numbers is 1, right? And I equals 3. When we take XOR of odd numbers, XOR of even numbers with the current value of I, because this place would be even index, because 0, 1, this would be an even index. Yes, this would be an even index. And if we take XOR of this and this, we will get 0, 1, 0, 1. This is what we want. This is what we have. Makes sense. If the target XOR is equal to 0, and what we are adding here is also 0, the numbers are same. Shit. I think we can literally see that this number and this number are same, like literally same. So this is wrong. This is wrong. Makes sense. This makes sense. Okay. Is this a rare case? If the target XOR is 0, that is the only case when we have a problem. Yes. And yes. Yeah. If the problem only arises at this point for the fourth test case. In the fourth test case, we have 4 here. Yes. Uh, 6. We have 6. 6. 6 is the smallest case where this problem arises. So we have at least a few numbers. Shit. We need to change one more number and this range. Yes, we can make the last number equal to 0 and not add the offset there, and we can add the off. We can add the offset here and here. But then again, it's shit. Yes, same problem again. We can have a 0 at the last position and take the required number, add the offset here, and take one of the numbers from the odd list, which is not equal to the required XOR, and add the offset to that number. Okay, okay. But shit, since we have already outputted the answer, that would not work. Size is n and yes, we'll just do this and iota a dot begin a dot end starting from 1, fill this thing up. And now depending on the required value, what we'll do is the third last value from a n minus 3, yes, third last value should be equal to or XOR plus offset. That is nice. So we need to add the offset somewhere which is different from I. And minus 2 equals I. Okay, and a and minus 1 equals 0. Now we have to add the offset somewhere to one of the odd numbers. And yes, to one of the odd numbers. If odd XOR, then a n minus 1 equals 0. And n minus 1 equals offset. A else that thing is not that, then a 0 equals 0 plus equals offset. We'll add the offset to the person. Okay. For n time equals 0, I less than n, I plus plus. Okay. C out AI space or new line depending on I equal to n minus 1. Okay, this has to be like fabulous. Here, instead of this, let's have an offset of 3. This is like 8. Okay. So this thing looks very nice. XOR of this, and this. Let's see. XOR of 1 and 3 is 2. XOR of 2 and 5 is 7. XOR of 7 and 6 is 7 and 6 is 1. Okay, so XOR is 1 here. And for nice. And then XOR of 2 and 4. XOR of 2 and 4 is 6. XOR of 9 and 6. 6 is 110, 9 is 8 plus 1. So this is wrong. XOR of 1 and 0 is 2. 1 and 3 is 2. That is nice. And then 2 is 10 and 5 is 101. And XOR of these two numbers is 111. And then 111 XOR with 6, which is 4 plus 2. So we turn off those two bits. This is what? XOR of 9 and 8. XOR of 9 and 8 is 1. Are we like not acknowledging? Yes, we are not acknowledging. God, I- Nice. Let's have a higher set here. Right. XOR of 1, 3, 5, and 6 is still 1, but XOR of 2 and 4, 2 and 4 is 6, and then XOR of 6 and 23. How do we write 23? 23 would be 16. Yes, 16 plus 5. 5 is, yeah, 16. Since this is also 16, so we can just ignore the 16. And 5, no, 16 plus 5, that is 7. 7 is 111. And we already have 6, so XOR is equal to 1, which is correct. Okay, this should work, this should work, this should work. Hello, how is everything going on? We are doing some binary things. This is the question. It's like pretty nice question. And in Q, I think it would be right this time around. And this was a good question. This was a good. I can only use was if I get this right. Okay. Code force is kind of surprising. And yes, so what is it that we are doing? We are initializing the A array, and to get the thing right, we only have to change the last three numbers. We are making the last number equal to 0, the second last equal to I, and the third last equal to XOR, the required XOR plus the offset. And now, yes, so at this point, the XOR of all the numbers at even position and odd position is same. All we have to do is find a place to add the offset. If the XOR is not 0, then we can add the offset here, right? And if the XOR is 0, then we'll add the offset the last at the first place. That is already 1 hour and 14 minutes. That is a long time. And Q, shit. Okay, I'll go to the washroom and I'll be right back in a minute. And hopefully, this is out of queue by then. Okay. Yep. Mm, that is really cute. Okay. This question is very good, but yeah, and this seems to be okay now. And we don't have any repetition. Yep, we don't have any repetitions in a row, so that is nice. Yes, that is nice. We don't have any repetitions. Yeah, cool, cool. This would work, and yeah, that this would be the end of today's stream. 1 hour and 16 minutes for this question, and we did 3 questions. This is nice. We did one question from yesterday, knowledge cards. Then we did garbage, garage, and then we did network question. This one was we figured out how what we wanted in this, but we were unable to, or I was unable to figure out how we get to that thing and the way. And then we did the editorial, and s- the way that we figured out the answer was like different, novel. Yeah, it was novel. And garage, this was also a nice question. This was also, I would say, yes, this one was very instructive. This one was very instructive because we had to figure out how to find numbers in a series. And there were 2 ways, either by taking offsets or by binary search. That was nice. And then even, odd, XOR, yes. But in this one, we messed up. We messed up. This will just work out in its own time in Q. And yeah, so for today, that would be the end of the stream. And thank you for being here. Bye. 3 hours and 23 minutes. That is nice. Yeah, 3 questions. Bye.